So in the module 2, okay, we're looking at the introduction to ARCmega 32 architecture. ARCmega 32 is actually the microprocessor chip that we're going to use, okay, sepanjang to, okay, in this course. Okay. So, okay, in this chapter here, okay, you will learn about the definition of computer architecture, processor operation, okay, and then we are looking what are the von Neumann and Harvard architecture, what are the difference between these two architectures, and then next after that we're going to see the architecture behind ARCmega 32. Okay, first let's look at the introduction part, the architecture. Okay, so let's look at the architecture and organization. What are the definition of this architecture organization? All right, so what is architecture? Okay, so architecture is how a computer system is designed, all right, and what technology it is compatible with. Okay, I think I need to sekejap ya. Okay, I need to sebab maybe you cannot see. Okay, so I just close that one. Alright, so the attribute of a system are visible to a programmer. Okay, means that this architecture here is how you going to design a computer. Okay, and then at the same time you want to see what are the technology is compatible with your computer design. Right, so the attribute of a system are visible to programmers, so programmer can see the attribute of the system. Okay, so this attribute have a direct impact on the logical execution of a program, such as instruction set. Okay, how you going to write the programs, so you need to know what is instruction set that available. Okay, number of bit used for data representation. Is it using a 8-bit data? Is it using a 16-bit data? So what is what we call here the number system that are going to use? Okay, is it a decimal number, binary number, or hexadecimal number? And then you're going to see what is the I/O mechanism, okay, and the addressing techniques. Okay, so in the what we call here, there are few addressing techniques available in order to do the data movement. Okay, so this addressing technique you will learn later in the next module. Okay, so there are two types of computer architecture. Ada dua jenis computer architecture. The first one we call it as a von Neumann architecture, while the second one we call it as a Harvard architecture. Okay, so what are the difference between these two architecture? Okay, so the von Neumann architecture is a computer architecture with physically single storage. Okay, you only have a single storage and a signal pathway for instruction and data. Okay, means that you share the same signal pathway for instruction and data. Okay, ingat lagi tak? Previous class, okay, you already learned about the fetch and execute cycles. Okay, in which the fetch, you're going to fetch the instruction from the program memory. Okay, so instruction are fetching from the program memory. Okay, so this is for the instruction part, and then you execute that instruction and save the result to the data memory. Okay, while for the Harvard architecture, a computer architecture with physically separate storage and signal pathway for instruction and data means that this one here you have separate storage and separate signal pathway. Okay, so let's look at detail the von Neumann architecture. Okay, sekejap ya. Okay, so let's look at this von Neumann architecture here. Alright, so this von Neumann architecture, you can see here, the computer has single storage system, which is a memory for storing data as well as to program to be executed. Okay, you see you have a code memory and as well as the data memory. And then this memory here share the same buses, the signal pathway. Okay, kamu nampak kat sini dia kongsi the same signal pathway. Okay, so in this system, okay, in this architecture, the processor need 2 clock cycle to complete an instruction, which is you cannot use any pipelining techniques. The pipelining is actually to execute another process before a previous process is done. It's something like you do a multitasking. Okay, that is a pipelining. Okay, so because you share the same buses here, you cannot do multitasking. Okay, kenapa? Sebab ingat lagi the fetch and execute cycles. Okay, means that first you need the CPU need to fetch the instruction from code memory. Okay, and then after it fetch the instruction from the code memory, then barulah you can execute that instruction and store it to the data memory. Because you share the same bus, you cannot do fetch and execute at the same time. Okay, kena buat one by one. Okay, so that's why it says that you need 2 clock cycle to complete the fetch and execute cycle. Okay, for the von Neumann architecture, it is a relatively older architecture, okay, and was replaced by the Harvard architecture. So most of the computer system now are using Harvard architecture, no longer using the older architecture. Okay, so this is the Harvard architecture, as you can see here. Okay, the code memory and data memory are separated and it has their own signal pathway, or it has a separate buses. Okay, so the processor can complete an instruction in one cycle if appropriate pipelining strategy are implemented. Okay, means that you can do multitasking in the Harvard architecture. Okay, so by using the, of course lah, you need to use the pipelining strategy lah in order to do the, okay, in order to complete an instruction in one cycle only. Okay, so most of the modern computer architecture are based on the Harvard architecture. Okay, so, but the number of stages in the pipeline varies from system to system. So this is the difference between Harvard architecture and von Neumann architecture. Okay, so next we are going to see what is an organization. Okay, so computer organization is typically referred to the operational unit of the system together with the interconnection. Okay, which is how features are implemented. Okay, so in this computer organization, it consists of hardware details. Okay, you know the hardware details that are transparent to the programmer. So in this case here, you know how many input output available. Okay, what are the input output available? So what are the addresses for the certain input output, because you're going to write down the program. So in order to write down the program, you need to know the hardware details. Okay, you need to know the detail of each of the hardware used. Okay, what type of RAM used? Okay, is it a SD RAM or is it a DDR RAM? Okay, and then okay, what is the input that available? Okay, and output available for the certain computer. Okay, so that is the organization. So many computer manufacturers offer a family of computer models, all with the same architecture. Okay, architecture semuanya sama. Okay, we use the Harvard architecture, but with a difference in organization. Cumanya dia punya organization of that computer are different from one model to another model. Okay, let's look at the contoh here. Okay, so this is the example of computer in 90s, early to 2000, and this is in 2010 and above lah. Okay, so what is the similarity between this computer here? Apa yang sama? Can you tell me what is the similarity of this computer here? Anyone? Siapa nak tolong? Sekejap ya. Okay, for those who just come in, okay, please sign in the attendance or already shared in the chat box. Okay. Okay, what is the similarity? Okay, the similarity of this computer here actually is the architecture. Okay, all of this computer here are using the same architecture, which is the Harvard architecture. Okay, of course lah. Memanglah you can see 90 also have a monitor, CPU, keyboard and mouse. Okay, but the similarity here is dia punya architecture, which is using the Harvard architecture. Okay, so what are the difference between the 90s computer with the 2000s computer and the new computer nowadays? Apa yang berbeza? What is the difference? Okay, more expensive, lighter. Other than that, siapa nak tolong? Okay, yes, the organization. Okay, you see the 90s here. If you can see the 90s, mana saya punya ni ya? Laser pointer. Okay, you see the 90s here. Okay, for the 90s, kamu tengok kat sini tak ada menggunakan speaker. Okay, there is no speaker in the 90s because all the computer in the 90s are used for the office work only. Okay, and then you see there is the floppy disk kat sini for you to save the data. Okay, and then your keyboard here. Okay, your keyboard here are using the serial keyboard. Okay, serial communication keyboard. Mouse also using the same communication, serial communication mouse. Okay, and then the monitor lah. Okay, you can see this monitor here. Okay, only support berapa pixel saja and all those things. Okay, while for the 2000s, okay, kita tengok yang 2000s. Okay, now you have the what you call here. Okay, you have the speaker. Okay, because in this 2000 computer become the infotainment system, which is you can play game, you can watch movies. Okay, so you need a speaker, right? So since you're going to play games, okay, so you have the graphical cards. Okay, and then you see the USB here. The USB is still using the not wireless lah. Okay, but it's use the USB communication for the mouse and keyboard. Alright, and then no longer floppy disk kat sini. Okay, it is replaced with the what we call here DVD or CD-ROM, and the inside here the RAM that use are different from this computer and this computer here. Okay, this computer use the SD RAM, while this computer here use the DDR SD RAM. Okay, DDR RAM. Okay, and then while the 2010s punya computer, okay, the computer nowadays, okay, you see here no longer have the wired for the keyboard and mouse. Okay, all are wireless. Okay, and then this is the flat screen compared to this one. Okay, this is using the LEDs. Okay, so this one is LED, LCD. Maybe you have the touch screen punya screen monitors. Okay, and then you have the USB. This one USB only USB 1.0, but this one here already USB 3.0. So the organization are different from one computer to another computer. Okay, so that is the organization. Any question? Ada soalan tak untuk organization? Okay, and then this one here, the CISC, RIC, you can read it by your own. Okay, what are the, what you call here, the difference between the CISC and RIC? Okay, let's look at the introduction to AVR. Okay, we were going to focus what are the AVR architecture. What is the architecture of Atmega 32 chips? Okay, the AVR architecture was designed by two students. Okay, so this is the history part lah. Okay, this is the history part. Okay, so I just skip this one here. There are many kind of AVR microcontroller with a different properties. Okay, except for AVR 32, which is a 32-bit microcontroller. All AVR are 8-bit microprocessor. Okay, so semua AVR is 8-bit microprocessor. Means that the CPU can work only 8 bits of data at one time. Okay, so this is the important things lah. Okay, that you need to highlight. Okay, you can send a data or you can send or read a data 8-bit data at one time. Okay, the data larger than 8-bit has to be broken into 8-bit pieces to be processed by the CPU. Contohlah, you had a 16-bit data. Okay, so you need to broken this 16-bit data to 8-bit by 8-bit data. Okay, so you need to broken this one. Okay, let's say like you have a 12-bit data. Sama juga lah. You need to broken this one here to 8-bit data. And this one to another 8-bit data. Of course lah, yang kat sini mungkin it only consists of 8-bit data. So you need to put 0, 0, 0, 0 kat depan tu lah. Alright. So make sure that you need to remember the size of the microprocessor that we're going to use is a 8-bit microprocessor. Okay, the AVR is a modified hybrid architecture. Okay, you see here. Okay, it's usually the hybrid architecture, which is you have the separate memory storage. Okay, you have the CPU at the centers, and then you have the data memories, and then you have the what we call here the program memory, and it has a separate buses. Okay, so this is the hybrid architecture. Okay, now let's look at the AVR family overview. Okay, there are 4 AVR family available. Okay, first is what we call it as a classic family, and then we have a mega, tiny, and a special. Okay, so let's look at the classic AVR family. So this is the classic AVR family. Okay, this is the original AVR chips lah. Okay, the classic is the original AVR chip. Okay, you see here. This is the ROM size for each of the chip. Okay, the ROM size. Contoh lah, we take this the first one here. Okay, kita ambil yang ni. Okay, we take this one here. Okay, the ROM size is 2 kilobyte. The data RAM is 1 to 8 byte, while the EEPROM you have 1 to 8 as well. I/O pin, okay, input output pin ada 15. We have a 15 input output pin. There is no ADC. What is the ADC stand for? Okay, there is no analog to digital converter. Okay, so that is the ADC. Okay, tak ada ADC, no ADC supported in this chip here. Okay, what about timer? Okay, you have 2 timers. Okay, this timer here is used to generate a delays. Okay, later you will learn about how to generate a delay by using a timers, or how to do a counting by using a timer. Okay, and the pin number and package. Okay, you have PDIP. Okay, bentuk, what is the PDIP? Deep inline package. Macam mana bentuk deep inline package? This one lah. The IC with, okay, that you something like this. Okay, while SOIC is that one, the square one. Okay, so DIP is the what we call here the rectangle one, while the SOIC is the square one. Okay, so that one is for the classic family, and then we go to the mega. Okay, the mega AVR. Okay, so every time you see the word at AT mega means that it belong to mega family. Okay, X ni dia punya numbers lah, dia punya series. Okay, okay, these are the powerful microcontroller with more than 120 instruction. Okay, you have more than 120 instruction. Okay, has lot of different peripheral capabilities which can be used in the different design. Okay, contoh, there are few mega fam series here. Okay, Art Mega 8, 16, 32, 64, 1280. Okay, so if you can see here, the number at the back of this Art Mega here will represent the number of your ROM size. Okay, for Art Mega 8, the ROM size is 8 kilobyte. The data RAM size is 1 kilobyte, while the EEPROM is 0.5 kilobyte. Okay, and then the input-output pin, 23. Have a ADC, analog to digital converter? Yes, has. All the Mega family has the analog to digital converter, which is you're going to convert from analog input to digital input, so that your CPU can manipulate that data or can do processing of that data. Okay, how many timers? Okay, so this one got 3 timers, and so this is the package. Okay, packaging. Okay, so now we are going to focus on this one lah, Art Mega 32. Okay, which is you have, since it is a 32, means that the ROM size is 32K lah, 32 kilobyte. RAM size is 2 kilobyte. EEPROM 1 kilobyte. What about the input-output pin? Okay, you have many input-output pins. For Art Mega 32, you have a total of 32 input-output pin. So you can put to 32 sensors or 32 switches. Okay, you have the 8 ADC scanners, 3 timers. Okay, so you need to remember lah this value here. Okay, pastikan you remember this value. Okay, value ni you need to remember. Okay, next we have a tiny AVR. Okay, so tiny AVR, so denoted by AT tiny. Every time you see the word AT tiny means that it belongs to tiny AVR. Okay, has less instruction and smaller package compared to Mega family. Okay, because it is tiny, so the size is smaller lah compared to the Mega family. Okay, can design system with a low cost and low power consumption using this chip here. Okay, there are 4 chips here available: tiny, 30, 25, 44, and 84. Okay, so this is the size of ROM, RAM, EEPROM, and I/O pin. And last but not least is a special purpose AVR. Okay, so the IC of this group can be considered as a subset of other groups. Okay, but their special capability are made for designing a specific application. Okay, such as you have the USB controller. If you're going to connect your microprocessor to a USB, you need to have this special purpose AVR lah. You need to buy this special purpose AVR. It also have the CAN controller, LCD controller for the display, ZigBee for the Bluetooth, internet connection, FPGA, and etc. Okay, so this is the part number of the special purpose AVR. Okay, and this is the ROM size, EEPROM RAM. What is the I/O pin, number of I/O pin, and special capability, and the special function of each of the ICs. Okay, so how to get familiar with AVR part number? Okay, so AT stand for the Atmel. Okay, which is the company that produce that ICs. Okay, Mega, Tiny, 90S belong to the groups. Okay, mega is for the mega group, tiny for the tiny group, while 90S is for the classic groups. Okay, 1 to 8 represent the number of ROM. Okay, what is the ROM size? For the tiny, the first number here represent the ROM size, and this one here, the number here represent the ROM size. Okay, any question up until here? Ada soalan tak? That is the overview of the AVR lah. Okay, now we are going to focus to ArcMega 32. Ada soalan tak?
Doktor,
Any other question up
doktor,
until here?
doktor, boleh tanya saya tak yang tadi Mega semua ni yang dibincang tu semua tu micro controller kan?
Okay guys, any question? Okay, if no question, then semua dengar. All of you can hear my voice. Semua dengar tak? Okay, so let's look at the ArcMega 32 pin out. Okay, so this is your ArcMega 32. Okay, this is dalam bentuk DIP lah. Dual inline package, and this is dalam bentuk SOIC. Right, so if you see here, for the ArcMega 32, you have a total of 40 pin out. Okay, starting from here, pin number 1 until pin 40. Okay, kamu ada 40 pin out kat situ. Okay, from this 40 pin out, okay, from this 40 pin out, 32 are dedicated to your input-output port. Okay, so 32 of them are dedicated to your input-output. Okay, the first 8 here, we call it as a port A. Okay, you see here, from pin 40 to pin 33, this is a port A. And then we have a port B from pin 1 to pin 8. Okay, next we have a port C, another 8 for the port C from pin 29 to pin 22 kat sini. And last but not least is port D, another 8 is port D, which is from pin 14 to pin 21. Okay, so total number of input output for ArcMega 32 is 32. Okay, I/O, total I/O is 32 pins. Okay, what about the rest of the pin? Okay, another 8 pins. Okay, another 8 pins are used for the VCC. Okay, first for the reset. Okay, pin 9 is for the reset, which is you want to clear all the register and restart execution of the function. So make sure that you put a switch and an active low switch to this pin number 9. Okay, whenever you're going to reset that program, so you just press that switch. Okay, so this is active low. Kenapa active low? You see the word reset, you have a bar. So this is an active low switch. Okay, you need to connect to active low switch. And then we have a VCC. Okay, at pin 10 and pin 30. Okay, kat sini is your VCC. Okay, so this VCC here, you need to provide supply voltage to the chip. Okay, so the voltage is 5 volt. Okay, cannot more than that. If more than that, then your chip will burn out. If below than that, your chip will not works. Okay, then we have a external. Okay, external 2 and external 1 at pin 12 and 13. Okay, this external here are used to connect to your clock source. Okay, used to connect to your clock source. Alright, and then we have the ARF. Okay, so the ARF here used as a reference voltage for ADC. Okay, if you're going to do the analog to digital converter, okay, you need to put the reference voltage here. Okay, at the pin 32. And then pin 30 is your supply voltage for ADC and port A, okay, which is you connect to the same VCC lah. So always connect a VCC with the same VCC. And last but not least, you have this ground here. Okay, pin 11 and pin 31 is your ground. You need to connect it to ground. Okay, so this is the Atmega 32 pin out. Okay, so make sure that you need to remember the Atmega 32, you have total of 32 input output pin. Okay, the number of port in the AVR family varies depending on the number of pin on the chip. Okay, contoh lah, if you have a 8-pin AVR, okay, so this 8-pin AVR has port B only, hanya ada port B only. Okay, if you have the 64-pin version AVR, okay, this AVR consists of port A through port F. Okay, 100-pin AVR, it has a port A through port L, and for the 40-pin AVR, which is for the Atmega 32, it has 4 ports, which is port A, port B, port C, and port D. Each of these ports here has 8 bit. Ada 8 bit untuk setiap port. Okay, so total is 32 lah for input output port. Okay, before you using this port A, port B, port C, and port D as an input or output, you need to program lah. Okay, you need to program first before you can use any of this port as an input or as an output. Okay, so how to program? Okay, later we'll see how to do the program. Okay, so each port has 3 I/O register associated with it. Okay, port A ada 3 register that you need to know. Port B also have a 3 register. Port C 3 register. Port D also have 3 register. What are those register? Which is we call it as a port X, DDRX, and pin X. Okay, so you just replace this X here, this label X with the A, B, C, and D respectively. Okay, so for the port A, okay, the register that associated with port A, we call it as a port A, pin A, and DDR A. Port B also have 3 register, which is port B, pin B, and DDR B. Okay, same applies to port C and port D lah. Okay, you have another 3 registers. Okay, so what this port B, pin B, and DDRB register do? Okay, for the port B, for the port X, okay, this one here used as a data register, which is when you're going to send out the data from CPU to output. Okay, every time you're going to send out the data from CPU to output, you are going to use the register port X register. Okay, what about the pin X? Okay, this pin X register is used as a data register for in or receive a data. Means that you're going to read a data, which from input to CPU. Okay, every time you're going to read a data from input and want to send it to the CPU, you need to use the pin X register. Okay, this one is port X, yeah? Register. What about DDRX? Okay, so this is the special register lah, DDRX. Okay, DDRX is used to determine either you're going to set or either you're going to initialize your port here as an input port or as an output port. Okay, how to do that? Okay, if you put 0, okay, if you send 0 to your DDRX, automatically your port become input port. Okay, if you put 1 to your DDRX, automatically your port become a output port. Okay, nanti later we will see more detail on this part here. Okay, how to do the program, how to set our DDRX so that we want to make that port as an input port or as a output port. Okay, any question up until here? Ada soalan tak? Sampai sini. Okay, so as I mentioned earlier, macam yang saya katakan tadi, each of the I/O register are 8-bit wide, and each port has a maximum of 8 bits, 8 pins. Okay, means that since you know that port A have 8 pins, port B have 8 pins, C also have 8 pins, and D also have 8 pins, means the data that you're going to send in or send out is 8-bit data. Okay. Okay. Therefore, each bit of the I/O register affect one of the pins. Okay. So this is the register that I told you earlier lah. Okay. So each of the port have 3 register, which is DDR, port X, and pin X, and this is your pin number. Okay, so for example lah, let's say lah this is your port A. So this register here we call it as a DDRA, port A and pin A, while the kaki kat sini, the legs here, the pin here, we label it as a PA7, PA6, PA5, PA4 until PA0. Okay, so total number of pin is 8 pin out. Okay, so the number of bit is also 8-bit data. Okay, so let's look at the DDRX register. Okay, each of the port A through to D in the ATmega32 can be used for input and output. Okay, so the DDRX wide I/O register is used solely for the purpose of making a given port as an input or as an output port. So this one here, the DDR actually to determine either you want to make your port as an input ataupun as a output. Okay, so to make a port as an input, okay, you need to give a 0 lah dekat your punya DDRX. If you're going to make your port as an output, you need to put 1 to your DDRX. Okay, how to do that? Okay, to do that, we're going to do some programming lah. Okay, so for example here, okay, you are going to make your port B as an output port. Okay, so nak jadikan port B sama dengan output. So what you're going to do is you need to make sure that your DDRB, okay, since this is output, you need to put 1 lah. Okay, so you need to make sure that your DDRB have 1, 1, 1, 1, 1, 1, 1, 1. Why you need to put 1, 1, 1, 1, 1, 1, 1 8 times? Why? Kenapa 8 kali? Why you need to put it 8 times here? Okay, because each of the port here has 8 bits, so that's why we put 1 here 8 kali, 8 times kat situ. Alright, so how to do that? Okay, we need to do a program. Okay, so first, okay, to send this value here to DDRB, you cannot directly send this value to DDRB. You need to send this value to your register first. Okay, so in order to do that, what you're going to do is first we use the LDI R16 OXFF. What is OXFF? Okay, OXFF, this is in hexadecimal. Okay, so OXFF, if you convert to binary, it become 1, 1, 1, 1, 1, 1, 1, 1. Okay, by using the 8421 method lah. Ingat lagi tak? This method here, 8421 method. Okay, F is actually a 15, 15. This is also a 15. So 8 plus 4 plus 2 plus 1, you get 15. So 1, 1, 1, 1, 1, 1, 1. So 1, 1, 1, 1, 1, you put to your R16. So what happened here? What is the LDI do? Load immediate means that you're going to load this number here to your register. What register? R16 register. Okay, so what happened here? R16, after you execute this instruction, R16 become 11111111. Okay, then after that, we're going to send this value from R16 to your DDRB. Okay, barulah kamu boleh send out this value to your DDRB. Okay, how to send out this value 11111 to your DDRB? By using the out instruction. Okay, so out DDRB R16 means that you take the value from R16, which is what is the value of R16 earlier? FF. Okay, and then send it out to your DDRB. So after you execute this instruction here, what happens is automatically port B sama dengan output port. Okay, so this is how we're going to make your port as a output port. So how to make the port as an input port? Okay, to make a port as an input port, so you need to put 0 lah to your DDRX register. How to do that? Sama juga lah. Okay, so this is port B. Okay, you're going to make a port B as a out. So yang ni tukar not output as a input. So what you're going to do? Okay, in order to make a port B as an input port, so we need to send 0, okay, to our DDRB. Since port B is a 8-bit size, so you need to send 0, 0, 0, 0, 0, 0, 0 lah, okay, to your DDRB. Okay, so how to do that? We do it by do a program. Okay, so load I R16 with 0x00 ataupun if you don't want to use the what we call here the hexadecimal number, you can also use the LDI R16 0B. 0B means that it is a binary number. So 000000000000. It is similar to this one. Or you don't want to send in the hexadecimal nor the binary number. You can also send in the decimal number. How to do that? Load I R16 kosong. Okay. We have 3 ways to put 0 to your R16. First, by using the hexadecimal number, or by using a binary number, or the third method by using the decimal number. Okay, so what happens after you execute this instruction here? So R16 become 0. Okay, next. Then after that, you send this value from R16 to your DDRB by using the output instruction. Out DDRB R16. So automatically after you execute this instruction, port B now become input port. Okay, so this is not output, input. Okay, any question? Ada soalan tak? Yes, you can use other register because in Mega 32 we have R0 to R31. Okay, we have total of 32 registers. Kita ada 32 register, you can use any register. But there is but. Because you see here, this one, okay, this instruction here use the immediate value. Okay, which is what is the how to identify the instruction with immediate value. Okay, every time you see the letter I at the back of the instruction, means that it's going to use the immediate value. Okay, every time you see the instruction with the that ended with the I, okay, you have LDI, then you have the SUBI, you have the what else? ADDIW, sub I, LDI, CPI. Okay, every time you see the instruction that ended with the I at the back, okay, you need to use from R16. You need to use the register from R16 to R31 only. Yes, okay. We can we uh we can combine input and output port at input and output pin in the same port. Okay, so let's look at this example here. Okay, so we need to define what happened to the pins when 0B01110101 is write into the DDR register as instruction below. Okay, so let's look at this instruction one by one. Okay, lines by line. Okay, load IR20OX75. What happened here? Okay, you are going to load this value to your R20. So R20 now has value 75. Okay, this is a hexa. And then load I R70OX0F. So what happened after you execute this instruction? R17 now we have value 0F. Okay, so this is in hexa and this is in the binary lah. Okay, if you convert this value here to binary, you will get 0111 0101. Similar to this one. 0F is 0, what is 0, 0, 0, 0, 0, what is F? 1, 1, 1, 1. Okay, and then you see here, out DDRA R20. Okay, so you send out the value 75 to your DDRA. Okay, so this is your DDRA. Okay, we look at something like this. Okay, it 8 bits. Okay, so you send out value from R20. What is value from R20? 75 ni lah. Nombor 75 you put to your DDRA. So what happened here? This value here, okay, will go to your DDRA, so it becomes something like this. Okay, so you see here, okay, this is the first bit. Okay, so this one, this is a PA0 and this one is a bit 8, which is we denoted it as a PA7. Okay, for the PA0, what happened to this PA0? Is it become an input or output? PA0. Okay, since you send 1 to your DDRA, so this one become output. What about this one? 0, it is become input. What about this one? Output. This is input, output, 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 and input. So you have 3 input and 5 output from the same port, which is your mixture of input and output at the same port. Okay, so next, out port A R17. Okay, so what you're going to do here, you are going to send value R17, okay, which is value ini, to your port A. Okay, you're going to see what happened to this output here. Okay, so what is the value of R17? This is the value of R17, 0, 0, 0, 0, 1, 1, 1. Okay, so you put kat sini 0, 0, 0, 0. 1111. Okay, you want to send it out. Yeah, this is your CPU, and this is your uh, IO peripheral. Yeah. Okay, so this is your. Okay, so what you're going to do here is, okay, this number that you're going to, so since this one here, this is your input, so the value here, okay, you cannot send out this value to the outside, okay, because this one here only used for the to read the value from outside to CPU. Okay, so since this one here, this zero cannot go to the outside, so by default we just put make it zero lah, kita just tulis kat situ zero. Okay, what about this zero here? Yes, because this one is output, so this value can go outside of the CPU. How about this one? Also can, because this is output as well. This one also can. Okay, so you can send this zero to the output. What about this number one here? Since this one here, this is an input, so you cannot send this value here to the outside. So what happened here? This one becomes zero. What about this one? This one is one. What about this one? Zero, and this one one. Okay, so what happened to the output of your port A? So instead of you going to send this value here, the value that go out from the CPU is 0, 0, 0, 0, 0, 1, 0, 1. Why? Because you have input here, so you cannot send the data out from this input. Okay, and last but not least, okay, this is what happened lah for this instruction. And the last instruction in R18 pin A. Okay, in means that we want to read. Okay, yang ni tadi out means that we want to write, to send out the value, and this one to read the value from pin A to R18. Okay, let's say lah, I padam dulu ya. Okay, let's say lah the value from the pin A, okay, the value that you want to read is from outside, okay, is 1111 1111. So what happened? Apa yang berlaku? Okay, let's look at the for each of the pin lah. Okay, for the first pin 7 here, can you read this value from outside to the CPU? Yes, because this is a input. What about this one? Can this value 1 go to the CPU? Cannot, because this one here you initialize it as a output, so automatically it becomes 0. This one also 0, 0. What about this one? 1, 0, 1, 0. Okay, you try to read this value here 1, 1, 1, 1, 1, 1, but end up you only can have this value here. Okay, due to this initialization of your input output port. So automatic R18, okay, sama dengan if you tukar dalam hexa, if you change the value here to hexa, you get 8 8421, which is 8A. Okay, any question? Sorry, I can hear you. I don't know why I cannot hear you. If you port A and pin A are same code, different. Okay, if you're going to read, okay, we need to read from pin A by using the in instruction. Okay, if you're going to send out the data, okay, we send out the data by using the out instruction, but using the port A. But it came from the same pin lah, dia akan datang daripada pin yang sama dekat sini. Okay, any other questions? If no question, maybe we can stop here. Okay, we continue next week. Okay, for those who just come in, okay, yang tak sempat sign the attendance, please sign the attendance. Okay, I already shared the attendance in the chat box. Okay, so thank you, class. Okay, see you next week.
Doctor. Doctor.
Doctor? Doctor?
Okay, just asking that, is it the DDR port and pin all share a similar physical slot in the Amiga? The answer is yes.
Doctor? Are you hearing me?
I cannot hear you. I don't know why I cannot hear you. Okay, I already changed the speaker output to my what we call here audio, my laptop audio, but doesn't work. Okay, the port can be output and input at the same time, depending how you initialize your DDR.
Can you hear me, Doctor? Doctor.
Okay, as I explained earlier, Josh. Okay, if you put 0 to your DDR, so automatically your what we call here your uh, pin become input. If you put 1, it become output. Similar to what we have here earlier here, macam kita ada kat sini. Okay, so this one here, okay, we write down this value here to our DDRX register. So automatically what happen is this pin 7, this is a PA7, become an input. Okay, this one become output. This one also output. Output. This pin become input. This one become output. Input and output. Yes. Okay, you can possible to assign 0 and 1 simultaneously at the same time inside your DDR. Only at Mega 32. Okay, no need to memorize the other family punya what we call ROM, RAM, all those things. Okay, only focus on the Atmega 32 chip.